Всем салют.
He's going to continue in the same vein.
Сейчас будет
Hello, everybody.
на мониторе QR-код.
A pleasure to see you all.
Задать свои вопросы.
I will show a QR code here so that you can
На всех ответить.
ask your questions, and we'll try to answer them going forward.
Начнем. Данный доклад будет о том,
This presentation
искусственный
will focus on the role of AI at SOC. We are already using it, so I will share some use cases with you. Next, we'll also talk about application of LLMs in InfoSec. And actually, I will finish with conclusions. I'm Gleb Ivanov. I'm an SOC analyst in the research and monitoring tech development team at Kaspersky Lab. Now, we do this in order to improve our defenses, so defenses provided by products. We'll also do some other things. So, the SOC we have consists of people, processes, and technologies. And naturally, the place of AI, be it DL or neural networks or ML, is certainly with the technologies unit. Now, people are already saying the first line is no longer needed. Well, we no longer have lines, just like Irina suggested, and our main objective is not to replace people, but rather to automate existing processes, so that, we can reduce the workload on our SOC analysts. Now, naturally, this race of defenders versus attackers is endless. And, as defenders, we are always playing the catch-up game. We need to learn to adapt to new CVs, new methods, new techniques, new zero days, and so on. Now, this leads us to this concept of, data-driven convoluting. So before we apply ML of this or that kind, we need to remember the golden rule that the data you are going to work with must be pretty much similar to the data used to train your model, which is pretty difficult, right? Because like I said, this data keeps changing all the time. What was relevant yesterday, for example, yesterday, we would teach our model to find specific types of malware, but today attackers will be using new methods or new types of malware. That's why we decided to focus on what's legitimate, so to speak, because this stuff is not as mutable. And thus, training the model using this stuff would be much easier. Sergey Soldatov talked about it all in 2019. If you follow the link, you can discover his presentation back then. And I'm sort of building on it here.
Функционирует так называемый автоаналитик.
So at SOC, we have the so-called auto-analyst, also known as Skynet. It is learning from data sets. Now, these data sets are effectively built by our analysts as they respond to various alerts. So, Skynet is being trained on what's considered true positives versus false positives. And, ideally, it should help us root out false positives. Now, the pipeline is like this. It's 100% the same alerts go into our B system, then Skynet will process roughly 35% of all the alerts. thus reducing the workload on our analysts. Now, we decided to keep it at that level of 35% because, this way it's pretty comfortable for us to also monitor the changes in how it works. So we feed it JSON data. So we've told our robot about the important fields, and based on the data in these fields, it is learning. And considering how it should make this or that decision. As the slide shows, red here corresponds to true positives, with blue corresponding to false positives. So when we're using such a robot, naturally not all fields in the alert event should have the same weight. I mean, it is obvious to us humans, not so obvious to robots, which means that, we need to tell the robot which fields to prioritize. Secondly, not all rules of detections must be processed by the robot, because we have rules where the price or the cost of error will be colossal. So it is best to summon a human being to do that. It's also important to do kind of a double checking on the food, quote unquote, we're feeding the robot. Because our human analysts can make mistakes and they will make mistakes. And as we do the double checking, we help them reduce the number of mistakes they're making, but we're also making sure that our robots gets proper training. At the same time, we assume that robots will also make mistakes, but we want to minimize this number of mistakes. Which requires monitoring and retraining. Now, that requires having an interpretability model. Examples of mistakes can be seen here. So you can see here that a detection rule has been triggered by port scans. So the key fields here include, for example, the client name. And shown here is the detection logic. Note, however, that the robot decided not to sort of consider the remote IP field, which was obviously a blatant mistake, so we had to retrain it. So this is the process. As we keep retraining it, it gets smarter and smarter. We are using ML not just for filtration purposes. It can also tell us the probability of a particular alert being generated by the client itself, and it's all based on the fields that have already been sort of configured in the alert and posted for this client. And frequency of specific alerts coming from a particular IP or a particular host is also an important consideration. So, and we also use ML to do anomaly search. For example, if we are seeing a wave of alerts, so it could be a glitch of the detection logic, among other reasons. Or maybe there has been a filtration mistake. There could also be a significant increase or decrease in the telemetry flow, which means that we are either putting too much strain on the client, or alternatively, it might mean we are losing out on some events. And also suspicious activity or user behavior analysis. Now, let's consider specific use cases. The first one is identification of unauthorized usage of accounts. So, for example, a particular user can be entering a subnetwork they've previously never used. So, for example,
Wi-Fi сеть.
this particular user has always used, their office device and the office network, but this time, for some reason, they are accessing it from a Wi-Fi network. Next one will be scanning file resources.
На различные там файловые ресурсы. Как вы можете видеть на слайде, у нас есть, где вот
As you can see in the slide,
идет черточка. Это там, где у нас всегда эта активность есть, и будет. Это может быть какие-то легитимные там, сервисные учетки, легитимные...
There could be, say, legitimate hosts or legitimate service accounts, but if you see a sudden spike or a sudden drop,
это уже как раз может вызывать...
that should raise some questions.
Это дело как раз нам расследовать. Также мы можем искать поиск чужих закэшированных билетов.
We can also start looking for cached tickets belonging to somebody else. So many tools out there that enable attackers to grab the tickets of a particular Kerberos user and put it in the cache.
Это можно с помощью вывода команды keylist.
Now, we can use a keylist command to do that.
Имя пользователя сессии.
So we have the name of the session user and the name of the user in the ticket. In many cases, you will see discrepancy between these fields because, for example, there are numerous accounts. For example, Petrov can easily have several accounts. Like Sidorov may have a domain account, like domain admin Sidorov, and so on and so forth. So there can be numerous exceptions here. But we can still look for unusual tickets. So, for example, Bob can have several new accounts sort of woven into the cache, something we've never seen before. That should raise questions.
Как это будет работать?
Now, since Skynet only reacts to false positive alerts, it can be trained to do filters for every detection rule. So, if we get, for example, over 20 similar alerts from the same client, and they all have the same pattern, like the same IP, or they're all related to something online, then our ML will create a valid request to filter all these alerts and send the request to our analyst, who will then double check why ML did that, which particular fields were analyzed this way.
И если что, мы ее можем поправлять, тем самым она будет обучаться на верных нам данных.
So we should be able to correct if needed and make sure that the ML is being trained on the right data. Now let's talk about LLM. Now, as large language models have developed so much over the past several years, naturally, so many submodels have been developed for specific purposes such as pen testing, reverse engineering, and so on. So this is, for example, is Geppetto. Which can be used for reverse engineering of malware. So if you see an unusual function, for example, Geppetto will tell you what this function can be used for. There is another model called Lilim, and it has been trained on numerous datasets from various InfoSec resources, which could be used as an assistant. So it can give you recommendations if needed. It can also develop documents for you and so on. Like previously mentioned about red teams, the application of LLMs for offensive purposes is sort of flourishing. Now, attackers can now develop malicious code using LLMs, or they can do phishing software. In human-like language. Now, LLMs can be used as an assistant tool by the attackers. Now, imagine that the attacker is doing some sort of fuzzing. So they have collected lots and lots of data points from various port scans. Then, they feed it all to the model, and the model will say, Now, it's best to access a particular service. And here is a POC for you.
Огромное развитие инцидентов с применением различного рода ИИ получило именно как...
There have been already numerous incidents involving AI, particularly deepfakes.
Новая техника там атакующих, что мы уже наблюдаем, как различными гендиректорами и могут там воровать или пытаются
So many people are currently trying to defraud others, pretending to be their CEOs or what have you.
Развитие безопасности это именно как
which means that there is a new vector for InfoSec, which is LM-SecOps. Now, organizations like Mitra or Avaspa have got very concerned about it.
Начал разработку своих различных
And they have started developing their own frameworks
на вот атаки как на самый искусственный там интеллект, так и
designed to protect, well, the AI itself from attacks and also to protect against AI-enabled attacks.
времени у нас роботы будут воевать.
Now, this means that very soon we'll have robots battling robots.
И беспилотный red team. Однако,
remember the previous question about unmanned red teams and unmanned SOCs? It's not that easy, though. AI is being currently implemented in various commercial off-the-shelf solutions. And it sounds futuristic, but still we believe humans will have a role to play. And we believe that LLMs should best be used as assistants, so we can delegate the routine stuff to them, such as doing technical writing. It can be used by IR analysts and SOC analysts. Because, for example, writing a report or filling out an incident card is certainly the routine few people love.
Также там LM-ки могут выступать именно в качестве ассистентов в выводе.
LMs can also be used as assistants when it comes to, say, doing the flags or collecting additional information.
Рекомендации, с чем также LM отлично.
And filling out some fundamental basic recommendations, LMs are already good at that. I will not be able to cover everything about LLMs in such a short presentation, but you can easily follow our podcast here. They're called Don't Fool with ChatGPT.
И различного рода вот инциденты связаны также с этими.
Don't fool around with ChatGPT. So, you know, these two podcasts cover some recent incidents as well. Now let's talk about conclusions. One of the key ones is that ML systems should be applied to improve the existing process rather than replace them. So they can hardly replace the wetware you're currently using, but it can augment your human analysts. And you may want to train your analysts to be able to work in Copilot if needed. Now, the best thing you can do is to provide the analyst with a full context. And this is where ML can be very handy. Like I've already said, you know, there could have been some, detections which you don't want your robot to address because the price of mistake can be colossal. So you may want your human analyst to respond to them. You know, as they tend to be more rational, more analytical, more predictable in a way. Like I said, ML is currently seen as a sort of one-size-fits-all solution, which is a bit too much, but it can certainly be used as the first line. Also consider some SOAR solutions out there.
Ну и также в ближайшее время искусственный там интеллект не заменит человека, потому что
in the near future, AI is not going to replace humans.
Работает на основе тех данных, что ему уже.
AI we see currently is a generative AI working off the basis of the data previously used to train it. So it's not ideal when it comes to totally new threats. While analysts, human beings as they are,
аналитическое мышление может анализировать все данные.
Can rely on their analytical capabilities, and they can generate valid hypotheses.
Будет больше развития.
Because of that,
различным аналитикам по поиску там угроз, именно red hunter.
We expect them to, the wetware, the human analysts, to stay in business, while ML can be delegated functions of technical writing and some other routine operations. Thank you very much. I'm ready to take your questions.
Да, спасибо, Глеб. Твое выступление действительно
Yes, thank you, Gleb.
шквал вопросов, их уже больше 20.
There is a flurry of questions, over 20 questions in the chat, and we don't have the time, really.
Ответить на максимальное количество.
Only 5 minutes.
Первый вопрос.
Question 1.
Как идет перепроверка после Скайнета? Насколько возможно?
How do you do this double checking post Skynet, so to speak?
Может быть, у нас есть.
Yes, indeed. There can be false positives and false negatives as well. So we collect some metrics to safeguard against that. Now, if Skynet has never responded to detection rules before, and currently we are seeing some flurry of activity,
либо еще неверно. И как раз
that could be a reason for sort of double checking it.
А как именно у нас вот Skynet?
At an early stage, we can see how Skynet
всех этих решений.
is kind of making all these decisions.
На ранних этапах мы можем вот обучить его на новых данных.
This way, at an early stage, we can train it on new data, and if the data is old,
у нас есть, так сказать, задача на ресерче, что занимается уже проверка всех этих метрик. Дальше мы говорим уже об этом всем о нашем.
We'll tell the research team to get involved, and then we tell the ML team to retrain it using new data. Thank you. Next one. Piggybacking on the previous one. Do you employ algos to discover anomalies? How do you process radically new data? Well, we give this new data some time to kind of ripen. You first needs to go through the chaos of ML. And once ML has been trained, once it ripens, so to speak, we will unleash our ML on the new anomaly search. Next one. Have you tried using graphs or graph-based models to discover anomalies? And if so, have you been successful or not? I'm not sure I can answer this question, though. Building different graphs is something that our ML people are doing. Here at SOC, we can tell them what we would love to see, and what they do, like the rest of it, is magic to us. Okay. Next one. What were the stumbling blocks you discovered as you implemented Skynet? Well, we started development in 2016, which means we have accumulated quite a lot of experience in terms of deploying and using it. And I mentioned some of the stumbling blocks we had. For example,
не давать роботу там обработку вот каких-либо детектов, этого раньше не было.
We had to add this tick that would enable analysts to exclude some types of events from being analyzed by the robot. Remember what I said previously, like 35%? Now, we empirically arrived at it. And we also lacked some important fields at first, which are currently being used by the ML to make its decisions. So we would add these fields over time, because in every detection logic, you will need different sets of valid fields. And as new detections come around, new fields are added, And also our telemetry system gets better and better, so the total number of fields keeps growing. Thank you. Are there examples of real attacks that would use LLM? For detection and automation and defending. Well, like I've mentioned, we're mostly interested in using LLM as an assistant. So our laboratory has got its own LLM, and we're giving it new data sets. We're also feeding it different prompts, so that in the future, it could potentially become something more than an assistant, like I've said already. We're currently using it for technical writing. Okay, another one. Are there rules that can never be processed by the robot? Are there cases that AI is apparently unfit for? I don't have an answer already.
Под различную детектирующую логику, то есть у нас, как я уже говорил, там аналитики могут делать ошибки.
Analysts will make mistakes. So, for example, an analyst can respond to a Mimikatz alert as a false positive, but, another analyst will notice that. So, our ML can learn from it all and can make the wrong conclusions if it doesn't see what the second analyst did. So there should be some exceptions, for sure. There are numerous questions regarding the way you're going to protect the model itself. Like, how do you check if there is some undisclosed functionality or malware to the model itself? Like I said, the model can be trained on erroneous data. Like, if you feed your model a bad data set, it will run off based on that. Which means that we have to perform rechecking of our model on a regular basis. So theoretically speaking, development of such attacks is possible. Okay, another one? Somewhat skeptical, though. What's the next stage of AI implementation at SOCs? If AI generates direct alerts, who will be responsible for mistakes? Will it be an engineer behind the AI? And how many engineers like this are you going to have? And what if you end up having more AI engineers than analysts? Well, that's the subject of the previous report about unmanned SOCs, isn't it? I'm primarily interested in the development of AI as an assistant.
Об этом также будут рассказывать коллеги далее.
The other speakers will tell you about automation and ChatGPT. I believe that the scenario you've described is a possibility, but it's also a judgment call. This will be the last question. Given all the event analysis methods you've described, can we expect self-learning models to arise without anybody overseeing them? When you have robots managing robots, well, theoretically it's possible. But there are so many caveats here.
Сейчас не буду их озвучивать, но
I won't even go into them. But theoretically, it is possible that models will learn from new data. But then, if you're disconnected from the internet, that's the end of the story, isn't it? However, humans can hypothesize, come up with theories, and do research. Models at the moment are incapable of that.
Это у нас, по сути своей, как продвинутый VT9. Он у нас думает, что...
Something was mentioned previously that AI today is an advanced version of T9. Thank you so much, Gleb. Let's give a hand to Gleb.